Suppose secant of theta equals 4, and you have to find all the other trig ratios between 0 and 180 degrees. Well, if secant theta equals 4, it is always really easy to find the reciprocal function. And the shortcut is that the ratio flips. So cos of theta will equal 1/4. Now we still have to find the other ones. So the strategy in trigonometry, I hinted at it yesterday. Strategy for trigonometry is draw a triangle. Now, if cos is a positive 1/4, there's two possibilities. What quadrants could it be in? According to the CAST rule, it could be in quadrant 1 because it's positive, or quadrant 4. So I draw a terminal arm in quadrant 1, I draw a terminal arm in quadrant 4, and I draw a triangle back to the nearest x-axis because that will include our reference angle. If cos of theta is 1/4, and here's my reference angle for both of these. Cos is the adjacent side over the hypotenuse. So that would tell me I'm allowed to label this as 1 and this as 4. And on this one, this is 1 and this is 4. Now, I drew both triangles because we're going to need it for part B. But in part A, do you see that they're only telling us to look between 0 and 180? So technically, I only need the top triangle for part A. But in part B, we're going to be solving this from negative 360 to 360, so we're going to need both triangles for part B anyways. You're going to get really good at a squared plus b squared equals c squared. So good that you can just put the number inside the square root that's going to be on that side. Do the mental math on your own, see if you get it right. A squared plus b squared equals c squared. What goes in there? Number one mistake is 17. So if you got 17, try again. That's the number one mistake. You're like, oh crap, I got 17. 17 would be right if it was the hypotenuse, but you're finding another side. Okay? This hypotenuse, so 4 squared is 16, minus 1 squared is 15. A squared plus b squared equals c squared. So if you know the hypotenuse, you can do c squared minus a squared to get the other one. So we get square root of 15. And now that you have that, could you tell me what sine of theta is? Absolutely. Opposite over hypotenuse. Could you tell me what tan of theta is? Absolutely. Opposite over adjacent. And if you know sine, you know cosecant, and if you know tangent, you know cotangent. Cosecant will be the reciprocal 4 over root 15. Cotangent will be the reciprocal 1 over the square root of 15. So we discern the exact values, means we don't put it into our calculator, we leave things with square roots. Again, you are allowed to leave square roots on the bottom, so you do not have to rationalize the denominator. And we have our answers. They'll all be positive, right? Because we're in quadrant 1. If we included quadrant 4, some of them would have to also possibly be negative. Part B. To the nearest degree, find the value of theta. So when you're finding theta, I actually have 6 equations now I could use. I would probably use I would use this one. I'm not going to use secant because I don't have a secant button on my calculator. I'm going to use cos because it was the first one that I found, so it's most likely that it's right. Chances are if I made a mistake, the other ones could be wrong. So this is most likely to be right. So I'm going to use cos. And whenever we're solving for theta, we always need, and what's going to be really important, is to find our reference angle first. And our reference angle, we're going to find cos inverse of this. To find your reference angle, you're actually looking at your triangle. Technically, our reference angle equation is identical to our cos equation. Because there's my reference angle in my triangle. Can you see that cos of my reference angle adjacent over hypotenuse would still be 1 over 4. But just a note. We're going to get into a lot of negative fractions in this course, but with the reference angle, your ratio is based on the actual triangle, and the actual triangle has positive lengths. So when you're finding a reference angle, you're always going to use positive values. Typical mistake is trying to do too much too quickly and forgetting that reference angles are always with positive values. So what we need to do right now is go to our calculator. I'll pull it up right here. And how do we get an angle when we have cos? We use cos inverse, right? So I'm going to go second, cos inverse. 1 divided by 4. I'm going to make sure my mode is in degrees. It was not, so I switch over to degrees here. Cos inverse of 1 divided by 4. I get a reference angle of 75.522. Again, I'll write down 3 decimal places. And then I'll read the question. What do they want me to round to? Oh, nice. To the nearest degree. To the nearest degree would be 76 degrees for my reference angle. So I just found my solution for my reference angle. You're going to have to go back and forth a lot of times in these questions and reread it. We want to find all the possible values of theta from minus 360 to 360. Okay? We found out, and I'm going to add it in here in degrees. I guess my diagram wasn't really that accurate, but this angle apparently is 76 degrees there for a reference angle. We have to find all the answers from negative 360 to 360. And usually when I talk about angles, we always have angles in standard position, and angles in standard position start on the positive x-axis at 0 degrees, right? In this direction in blue, those would be 2 positive angles that end at those 2 places. And this direction in red would be the 2 angles in the negative direction. So now I'm going to write them out, and I sort of split them up that way. If I have negative and positive, I do my positive ones first. They'll go from 0 to 360. Can you see that my answers for theta will be 76 degrees? That's my first positive one. And my second positive one, does it make sense that you would go all the way around and subtract your reference angle of 76? Can you see that as a visual? All the way around 360, subtract 76. That will give me my second answer of 284 degrees. Now, when I think about my negative angle, I actually use positive numbers first. Like this one is like going to the 4th quadrant. So if you went all the way around, that's 360 minus 76, I would get negative 284. I'd figure out that the answer should be 284, and I add a negative at the end because I'm going in that direction. Right? This one here, and you see that that is obviously negative 76 degrees. And you will get lots of questions like this, where you have to draw a triangle, or in this case we had to draw two triangles, find a reference angle, figure out what your answers are. So circle questions 9, 10, and 11.